Uh, Good morning, dear students. प्यारे बच्चों, गुड मॉर्निंग।
Good morning, sir. Good morning, sir.
मैं आप सभी बच्चों को
Morning, sir.
मैं आप सभी बच्चों को गुजराती नए साल की शुभकामनाएं देता हूं। आप सबको साल मुबारक, आप सबको हैप्पी न्यू ईयर।
Happy New Sir.
और मैं
Happy
आई
New Year.
वेलकम यू फॉर द 9th grade chemistry class on 16th November 2020. My dear students, once again a very happy new year. The new year may bring the prosperity, peace, happiness and a good health in your life. Uh, Let us start our class for chemistry. The various topics that we are going to study today are the atomic mass unit, relative atomic mass, and we will study about the atoms and molecules. So we'll study atomic mass, we'll study relative atomic mass, and we'll study about the atoms and molecules in today's class. Let us move forward. To begin the class, let us revise what we have studied into the previous class, my dear students. So in the previous class, my dear students, we have studied about the symbols of the various elements. We have studied that Dalton was the first scientist who suggested the pictorial symbols, and you can see on your screen that there are various pictorial symbols which was given by Dalton. After Dalton, my dear students, there was a scientist whose name was Berzelius. Berzelius actually was the scientist who suggested that the name or the symbol for the elements can be taken from their names. So Berzelius was the first scientist to suggest the symbol for these various elements from their particular names. Then we have started giving the uh, symbol or to the various elements based on their names. So, how did the names were given? Let us, so generally to give the symbol to the elements, we have started using the first letter. But before that, my dear students, there were few other techniques also were used. For example, the name of copper was given from the place from where this copper is obtained, and that was Cyprus. Same way, the name for gold is given from its English word, that meaning yellow in color. So, from the color and from the place from where they are obtained first time, the names were given. But then a new organization named IUPAC came into the existence. This IUPAC is the organization. Its full form is International Union of Pure and Applied Chemistry. So this International Union of Pure and Applied Chemistry came into the existence, and this IUPAC had started to giving the names as IUPAC had started to approve the symbol for the various elements. To write the symbol of any element, there are some rules that we need to follow. So the first rule is we should take the first letter of the name of the element, and it should be written into the capital form or it should be written into the uppercase. Same way, my dear students, we can choose the another letter also. So we can choose the another letter from the name of the element, and that letter should be written into the lower case, not in the uppercase. So you can see here from the example that if you write the second letter even in the uppercase, then the second letter, then such name is not approved. Same way you can see that cobalt should be written capital C and small o, but not the capital C and capital O. Same way, my dear students, while writing the name of the symbol, it is not necessary that the first and second letters are also only taken. For example, if you want to give symbol to the aluminium, my dear students, we write the symbol of aluminium as A capital and small l because and here we have used the first and second letter. But it is not necessary that all the time you take the first and second letter for the symbol. For example, chlorine, when we give the symbol, we have used the first letter and then the third letter. Same way when we give symbol to zinc, we have used the first letter, we have used the first letter and we have used the third letter. So any letter from the name of the element we can choose to put into the symbol as a second letter and it should be written into the lower case. Sometimes what happens, some symbol of the elements are taken from their Latin, Greek or German names. So there are few examples from which we can understand the symbol of various elements which were taken from their Latin or German name. Let us first look at the iron. Iron in Latin it is known as the ferrum and that is why the symbol is taken as Fe. Sodium in Latin it is known as the natrium and that is why the symbol of sodium is taken as Na. Potassium in Latin it is known as kalium and that is why, my dear students, we have taken the symbol for potassium as K. Now my dear students, I would like to give you a few more examples for which we have taken such Latin, Greek or German names. You can see for silver, my dear students, we have taken the symbol Ag, which is Argentinum. Same way, my dear students, for gold, we have taken the symbol, or IUPAC had supported the symbol AU. This AU, the AU in gold, my dear students, represents aurum. Same way, my dear students, for the element lead, we have chosen the symbol Pb, which comes from the name plumbum. Same way, my dear students, for mercury, we have taken the symbol Hg that comes from the hydrarigium. So please remember, my dear students, that there are very much or there are good number of elements where we take their symbol from their various other languages like from German, from Latin or from their Greek names. This is a very important line for you to understand that each element has a unique symbol. So the symbol of two elements does not resemble, the symbol of two elements are not the same. Now I will explain this with few examples. See, if you write C, that represents carbon. But if you write Cu, that represents copper. But if you write Co, then it represents cobalt. If you write Cl, that represents chlorine. If you write, so you can see that just from C, you have so many symbols that is available, but they differ by their second letters. So each element, my dear students, should have a unique symbol and no two elements can have the same symbol. Please remember this. Same way, my dear students, when you write H, it represents hydrogen. When you write He, it represents helium. When you write Hg, it represents mercury. So this way, my dear students, same way if you look at, if you write only S, it represents sulfur. If you write Si, it represents silicon. If you write Se, it represents selenium. So this is how, my dear students, each and every element has a unique symbol which is not similar to the another elements. Now, my dear students, we have finished studying about the giving symbol to the various elements. Now, my dear students, we are going to study few more topics here in the today's discussion. Let's move forward about the various discussion of today. Let us move and study the next question. Let us pay attention, my dear students. The next topic that we need to study about is about the atomic mass. So the question, what is atomic mass? Atomic mass is the mass of one atom of the element. Atomic mass is the mass of one atom of the element. So the mass of one atom of the element is called atomic mass. The mass of an atom is measured in some units. Which are the units in which atomic mass is measured? Now you know we want to measure the mass of one atom. To measure the mass, we need some units. So what are those units in which this mass of an atom can be measured? The mass of an atom is measured in a unit called atomic mass unit. The mass of an atom is measured in a unit called atomic mass unit. The small symbol is AMU, presently called U, only U. Nowadays we call it U, which means unified mass. So according to the IUPAC, International Union of Pure and Applied Chemistry, initially it was the unit for measurement of the atomic mass was considered as AMU, but nowadays it is written as unified mass. And the symbol is small u. So it is the symbol unified mass in which we measure the atomic masses. Now, my dear students, we need to understand about the definition of atomic mass units. So what is atomic mass unit or define atomic mass unit or define unified mass? If any of such question is asked, you can write this answer. Let us have a look to the definition of atomic mass unit or unified mass. One atomic mass unit is a mass unit equal to exactly, please remember, is equal to the exactly 1/12, that is 1 divided by 12, the mass of one atom of carbon 12. Now, carbon 12 is the isotope of carbon. We will study about isotope later, my dear students, but you need to write carbon 12. It is very much essential for this definition. Once again, let me read the definition for you. You need to learn this definition of the atomic mass unit, or you need to learn the definition of unified mass. Atomic mass unit or unified mass, my dear student, is the mass unit equal to exactly the 1/12 of the mass of the one atom of carbon 12 isotope. With what respect do we find the relative atomic mass of the element? So, my dear students, we need to study now that we have just seen. You have just seen, my dear students, that we take the mass, we determine the unified mass on the basis of the carbon 12. So whatever the mass we take the mass with reference to the mass of the carbon 12 which we divide with 12. So what is the reference for this atomic mass we generally use? The relative atomic mass of all elements have been found with the respect to the atom of carbon 12 isotope. So this mass what we get is known as the relative mass because all the mass are related to the 1/12, 1 by 12, the mass of one atom of C12. So on the basis of this, you understand, and that is why it is known as the relative atomic mass, my dear students, because it is related to the carbon. Now, my dear students, we are going to study the next question or next point. Explain how relative atomic mass of an element is determined with an example. Now, my dear students, we need to understand with the example that how do we decide the relative atomic mass. We have seen that the whatever the atomic mass, the mass we determine, this mass is related to the carbon 12 isotope or to the mass of the one atom of carbon 12 isotope. So with what, my dear students, we determine the relative atomic mass of an element. Let us try to study, let us study this, let us understand this with some examples. Let us try to understand the relative atomic mass of an element is determined with an example. Now we will take an example so that you can understand this well. Imagine a fruit seller. Think about a person who is selling fruit. Fruit seller does not have standard weights. The fruit seller was not having weights. The fruit seller was not having the weights to sell the uh, the fruits in a particular measure. To measure the mass, so he has to determine some weights as standard weight. Now the fruit seller has to determine some weight as a standard weight to sell all the fruits. So he will determine some weight as a standard weight to sell the fruits. Fruit seller takes one watermelon and says the mass of the watermelon is 12 units. Now what the fruit seller do? The fruit seller takes one watermelon and he says that that watermelon has 12 unit has 12 units or 12 fruit mass units. You can easily understand that he says that this watermelon weighs 12 fruit mass units. This watermelon has the mass of 12 fruit mass unit. As we have seen that we have divided the mass of carbon 12 with 12. So that is why this watermelon represent our carbon atom. So now to standardize the weight, this fruit seller determine or take one watermelon and consider it as a standard weight, and he says that this watermelon weighs 12 fruit mass unit. Fruit seller makes 12 equal parts. Remember here the word equal is very necessary. So the fruit seller makes 12 equal parts of watermelon and consider each part as a one fruit mass unit. Now what he did, he cut those watermelon, he cut that watermelon into 12 equal parts and each part he has considered as a one fruit mass unit. As we have taken one AMU, as we have taken one AMU, my dear student, as we have taken one AMU, the fruit seller have chosen, the fruit seller has chosen one FMU. So, my dear students, we have seen that the fruit seller has chosen one, the fruit seller has chosen to standardize the fruit mass unit. The fruit seller has chosen one watermelon. He divided the